Hey everyone, this is Evgeny, and today we continue our sessions about experimenting with different features from AI agentic world. So today I'm going to show you a bit different technique how you can use your MCP servers with scripting, and we'll see which benefits it gives you. So join me and let's take a look at that together. And by the way, before we continue, if you want to know more about that, if you want to learn how you can build your own agents using LangGraph, LangChain frameworks, we have tons of different tutorials for you prepared already. So check the link, everything is there, and you can learn a lot of stuff from these tutorials. And meanwhile, we continue. Okay, here we are. So previously we talked about the way where MCP is not so good enough, and we introduced CLI tools for that. And this time I want to show you how you can still be very productive using MCP, like how you can skip or avoid all these minuses that MCP has. And well, maybe it's not a standard way, just an experimentation, but still you can try it on your own and see if it works. It's like if something from these experiments work for you. All right, so we start with usual MCP setup. Let me define some basic stuff first. So I have GPT-5 Mini for reasoning. I have system prompt as a coding assistant, like it's the same example as previously. I'm still working with GitHub for simplicity. And first of all, let's give a try for MCP, like pure MCP way of doing things. So I'm defining MCP here. It's everything from previous video, right? We have MCP connected, we have MCP tools loaded. If I enumerate them, it's 44. It's like pretty a lot, right? It's for a single MCP server. And so then I have an agent with system prompt and MCP servers, MCP tools connected here. So the same thing, I'm asking for something which requires several MCP calls to GitHub, and this is use my authenticated GitHub account, check my 3 most recent updated repositories, read each README, and tell me like reason something on that, and show me the results, right? So it's several MCP calls needed here, several calls to GitHub. And let's give it a try. So I'm running it, and we'll see probably the same result as we saw already previously, right, in the previous video. All right, we are there, and it looks more or less okay. Like we have a get me call to MCP, have some responses back, and we check the whole output. It's even loading the README files, right? It's very long content here. So this is the classical way of how MCP with agents work. And what's the problems of this? Well, basically there are a number of issues here. I will only show you two, the most significant ones. So if you go to Langsmith, and so what do we have here? Let's check the first model call to OpenAI. And it's pretty clear, right? We have the system message, you record an assistant, and the user message was user my authenticated GitHub account, check my 3 most recently updated repositories, and this, all the stuff went to the LLM. Everything looks good, right? There's one exception here. We also providing all these available tools here. It's not part of messages, it's kind of metadata that we are sending to LLM, but this is needed, right? Once we registered our MCP server, it provides all the possible functions that MCP has. And for example, like if you open this tool, like here, just look at that. You have a tool name, you have description, the more complex one, you have a list of parameters with description, and it's very heavy list, right? And if I open this one and that one, so all this information goes to LLM, right? Just look at that. And if you imagine, like I have 42 functions, tools for a single MCP server, and with the era of MCP, where you have MCP almost for everything, your agent can be loaded with hundreds of MCP. So you have immediately like several thousand of these functions, and everything goes directly to LLM, to each LLM call. So this is really problematic because, well, it can be really confusing. Like the more information you're providing here, to LLM, the more confusing it is for LLM, right? It can start mixing things like make wrong decisions, forget about tools. So this is really a big drawback of using MCP because you're not controlling it. It can be connected, attached on dynamic nature that you have just to process it. So this is the real issue here. It's number one, right? And another thing here is that whatever the tool outputs, it goes to the context. So you're filling your context window with this information. Like for this smaller use case, maybe it's okay, right? Because, well, if you think about that, okay, probably README content is heavy thing here, right? It goes into the context, it eats your context window, you're paying for that because it goes through the LLM each time. And maybe you don't need all this information, but this is another drawback. Like just imagine if your MCP is not this one, like GitHub, it could be a logging system like Datadog, for example, where you have like hundreds of events from Datadog in each call, and then your context window will be automatically filled with this very irrelevant probably information, right? So these two things we are trying to fix today in this session, in this experimentation. And idea I'm trying to show you is called MCP-as-code or scripting MCP or something like whatever way you call it. But the idea is very simple. What we can do, we can introduce several concepts here. First, we have the concept of skills. And this is progressive disclosure. So by doing this progressive disclosure, we're showing only part of information which is needed. Because again, here we don't have anything like, right? We are showing immediately all the information available, and this is really overwhelming. So we are getting rid of this by doing these skills and progressive disclosure. And the second one, we are trying to replace the MCP tool with scripts or with programming. Well, why? Because the LLM, like basically LLM is trained on data, right? And MCP is not the data it was trained in the first step. But at the same time, LLM knows pretty well how to program, for example, how to do the Python programming. So what we are trying to do here, we are trying to convert our MCP calls to Python programs that are extractable by LLM using this disclosure thing, so step by step. And this is something I wanted to show you. So how it looks like, it's pretty simple, kind of my favorite word, right? We have a skill here, and the skill explains, let me close this maybe, it's there. So we have a skill, and skill explains like the first level, for example, it says, okay, when you're working with GitHub, you can use the skill. When it's needed, then the skill is loaded the whole, and here we have a workflow explanation. And basic thing here is that you, as an agent, you have several scripts, like you have connection, Python, right? You have some other functions. And what you should do, you have a list of available systems, like GitHub MCP is the first one, and there you have 44 tools. And we're not saying which tools are those, so we are not polluting the context yet. We're only saying that if you're interested, if you want to do something on GitHub, you have 44 tools for that. And they're in this GitHub MCP server folder. So do your research, but only if this is really needed. And then the expectation would be that the agent goes to this folder and research, like we have one Python file per tool, and then it can derive from the tools, from the file names, which tool is needed, and only then it goes deeper and learn the content of the file. And there we can provide more information. So how it looks like, we have a servers folder. Here we have, for example, two MCP servers coded like LangChain docs for simplicity, right? And GitHub MCP server. And if I go inside, look at that. I have 44 Python files there, one per tool. And for example, if you go to this get me, let me spot it here, get me Python. Right, so what we have here, we have a pretty heavy explanation that this is a wrapper for get me, and here's what the function can provide you. And basically, as an agent, what you need to do, you need to write a smaller Python program which makes a call to this get me, providing the session, and the session goes from connection. And this is all explained in our skill. And even if you think that the output can be bigger one, right, you can output it not to the context window, but to output file to external file, and then maybe you can maybe have some other algorithm to analyze it, right, and to do something with that. And basically that's it. So inside what's happening here, we are making tool call for get me, providing a list of arguments. We have results, and then based on that, we're just emitting it back. So this is the total substitution of MCP server by calling real MCP server. And again, before I'm running it for you, like to allow you to see how it works, we have the skill, we have the first level explaining that skill is responsible for a couple of MCP servers, and this is GitHub and LangChain docs in this case. We have a second level of progressive disclosure here explaining how to use this, that you have to run, like, for example, you have to run connect first, and then you scope this connection, run the functions. Well, you can combine different functions. For example, if you have any processing, you can also implement it in Python code, which can be part of this as well, right? So all this information is in the skill, and then third level, we have this folder with files, and then based on the names, the agent can grab something like, for example, delete file. Okay, I need to delete a file. It goes inside, and there it can read additional information. So what this function performs, what kind of arguments is there, but again, it's not loaded on the startup, only when it's needed. So that's the raw idea. All right. And now I think it's time we can give it a try and see how it works in practice. So what do we have here? We are constructing a new agent, and we have the same system prompt. We have skills middleware, and this one from deep agents. So this skills middleware loads our skill that I showed you already. We have file system middleware, so it's possible for the agent to research in file system, list all the Python functions available there, analyze them, read them, all this kind of stuff. And we have this shell tool middleware, which allows to run Python directly using the scripts. It's pretty simple, right? So this is how a graph looks like. We have several middlewares here and there. We have shell, this agent loop as well, and basically that's it. So what we are doing right now, we are running the same agent with the same test prompt, but with this updated schema I already showed you. So let's give it a try and see how it works. Okay, here we are, and let's check how it differs from the previous run. So basically what's happening here, we have the same user requests like GitHub accounts, recently updated repositories, read readme, etc., etc., etc. So first it starts, okay, it thinks that skill needs to be loaded, right? And goes here, it reads the skill, MCP scripting, gets all the information there, and here it realizes that okay, it needs to investigate the directory, it gets it back, and it starts reading the files it thinks that may be helpful for performing the job, right? So it reads the file. Here we have search repositories wrapper. The first one is read, then it reads something else, and this is get file contents for in readme. This is really clever solution, right? And then it reads the get me as well. So it knows 3 methods already, like it cherry-picked them from the whole folder. And then what's there, it starts to produce code. And well, I'm not going to go deep into this thing, but just generate candidates, readmes, dev try readme. So it implemented some really complicated algorithm how using these methods and functions to access MCP, to read files, to do the investigation. And this everything is on the fly, right? And even the error processing here as well. But basically, if you have such code, maybe you also have to automate this as well. Just you work with your agent, you observe that the some pattern repeating all the time, then maybe you can also hard code it as well as an algorithm, right? And then basically, look at that. It created single Python program that utilizes all 3 functions at the same time, performs the calculation. I never asked for that, but the agent was clever enough and makes a single call and produces the result. That was really clever, like single program that utilizes all these methods automatically in one program. That's great. All right, that was it for this interesting technique. It was only an experimentation, so you can take it and do something on your own. I hope you found the ideas very interesting. It solves a lot of problems which current MCP implementation has. And it was me, Evgeny. Thanks a lot for sticking with me till the end. I really appreciate it. And sure, we'll see each other in the next videos about all these agentic worlds and all different experimentations. Thank you. Take care and bye-bye.